can look at this while you guys look at my, this meeting is being recorded. So by staying on, you're consenting to being recorded. Santosh, you started the recording? Okay. So we'd like to ask that you mute yourself when you're not talking or asking questions once we start. Consider turning off your camera during the presentation so we can focus on the presenter and their content. We have a raise the hand feature in Teams near the smiley and the hand, so that we can pick on, who to call or decide who to call when we get a chance for questions, or we can do the chat window while we're talking. All right, today's agenda, the welcome and announcements that we're doing, and it's being recorded again and available on YouTube. There's a link further on. Facundo is talking about GitOps. Do you want the short or the long version read? Do you want me to read all of it, Facundo, on the teaser, or are you're gonna?
Just a quick one.
Okay. Okay. So basically, we're talking about Git, Kubernetes, continuous delivery, and particularly ArgoCD. But when is it an extraordinary fit? I guess is the appropriate question in there. All right. So here's the members of the board that do present WNTUG in Orlando Code Camp: Santosh, myself, Tim, Todd, Tanner, and our member at large, Brian, who may be on the call or at other meetings. Although everybody, look out for Tim because he was injured his back the other day, so we don't know if he's going to be on for the meeting, but we're sending him our well wishes. And we have our recently changed OneTug.net URL versus the .org. For those of you who maybe haven't been around lately, but we have pointers on there for our Meetup, our Twitter, our Facebook, our YouTube, our LinkedIn. But if you need to get a hold of us directly, it's board@onetug.net. And we don't have any meetings to announce,
we do. So next month, Jamie Phillips is going to be talking about, one second, I'm pulling it up. Jamie Phillips will be talking about Kubernetes and containers for .NET developers.
Okay, well, that ties in well with this talk then.
Yep.
Kubernetes is everywhere, and containers are everywhere. So that'll be good. I'm assuming that's going to be is that the first, or well, we're going to figure out the date and announce it. But stay tuned on Meetup and Twitter to find out.
It will be on December 9th at 7 p.m. EST.
Okay. So second, I don't have my calendar in front of me. Is that a Thursday also? Or?
It's a Thursday.
Okay. So second Thursday. We don't have a monthly sponsor this meeting, but if you'd like to sponsor, or we also give away prizes if you're interested in giving away things for raffle, you can contact us at board@onetug.net. And I'm facing the wrong way. We like to do community announcements here. If anybody's got anything that they've published or some sort of things along that lines of something they want to tell the world, if you can, come off or raise your hand or come off the mute and say, or job postings also, that you're looking for somebody. Sometimes we have recruiters in the audience who have something. Okay, so with that, did it skip? I think it went through the last. Now you're seeing my desktop, which is not. Okay, well, it all went away. So stop sharing. Anyways, so that I skipped the last one, so let me pull that up. I think I hit it twice. All right, let me bring this up. All right, now we're on the wrong monitors again, but I'll go through it. Facundo is a solutions architect at BoxBoat, IBM Company. He's focusing on helping teams adopt containers for some time. He started his career as a .NET developer, working downtown with Santosh, and eventually found his way, well, not before that, but at one point he was, and eventually found his way into the DevOps world. All right, with that, I am going to, once I get the right thing, which wants to disappear on me, stop sharing and hand it over to Facundo.
Very cool. Thank you. All right. Can everybody see the slides?
Yep.
Mic check. Can you hear me well?
Yep.
All right, perfect. All right. So today we're going to talk about using GitOps for deploying frequently. And what it's inspired by, I'm not sure if you're familiar with kind of the trendy DevOps movement where they talk about the power of using DevOps to gain kind of elite status or high performance status as an organization so that you can to ship more code, ship a lot more features, and provide a lot more value to the business, right? So if you think of like the top companies out there, like the Microsofts, the Facebooks, Amazons, they have figured out how to deploy quite frequently and also essentially keep up their systems quite stable. So it kind of goes against the grain of what traditional IT from several years ago used to think, which was, the more frequently that you deploy, the more chance and risk of destabilizing your system, right? So through these top performers out there in the industry, they've proven that just because you deploy frequently, it doesn't mean that you're going to destabilize your environment. And so you can have both. You can have stability and you can have high deployment frequency. A little bit more about myself. I currently work for a boutique consulting company that focuses on containers. And I think actually the next speaker that you have scheduled, Santosh, for the next meetup also used to work at BoxBoat. So his name was familiar. I used to be a .NET developer, and essentially through being a .NET developer, I've experienced quite a bit of deployment pains in the traditional enterprises. Eventually, I found myself into the DevOps world, and eventually I found myself into the open source cloud native Kubernetes world. So my goal for you today is not necessarily to teach you Kubernetes or GitOps. I just want to inform you so that you can be aware, be informed that you can promote code in a different way, and it doesn't have to be through the typical dev, test, staging, production environments that we know to love or hate. If you want to connect with me, feel free to add me on LinkedIn. I do have a Twitter account, but I'm not very active on it. And I used to blog quite a bit on gaunacode.com. There's still lots of content out there. I just one day I'll pick it up again and I'll continue to blog some more. A little bit more disclaimers. These are my own opinions that I'm still working on. The GitOps world is relatively new within the cloud native Kubernetes world. So things are changing constantly. And I will talk a lot about containers and Kubernetes. And this is kind of the scope of this presentation today. And, if you're not too familiar with Docker or Kubernetes, I can give you a quick, description of what each of them are. So essentially, the power of using something like Docker is that you can package up your application and all the dependencies for your application, like runtime dependencies, like your .NET Core version and whatnot, into a little package that will be run on any environment the same way. So in a way, it gives you kind of the same benefits that if you were to deploy your application to a virtual machine, and then you take a snapshot of your virtual machine and you try to spin it up somewhere else. Sort of the same benefits, but the promise of containers is that it is extremely lightweight and really, really fast to spin up a container. So this gives you a lot of capabilities because you can essentially start creating environments that are very immutable, and you can start destroying your environments when you don't like them, and you can adopt new deployment methodologies like the one I'm going to show today. Then Kubernetes is essentially a way for you to host your containers at scale. So it gives you a nice API where you can define an entire environment composed of many containers. So if you think of a front end and a back end, typically a application that is a front end back end application will have 2 Kubernetes deployments, one for the front end and one for the back end. And when you tell Kubernetes, here's my application, Kubernetes will figure out where to deploy your application. Okay, so high level, Kubernetes is for orchestrating the containers, and your containers are how you package your application. Okay. Santosh, I know that you probably have that discussion quite a bit as well. Is there a different way that you want to explain Docker and Kubernetes before we jump into GitOps?
No, I think it's fine. You can move on, I guess.
Okay, sounds good. All right. So what is GitOps? Imagine that Git is always the source of truth. And then you use Git to perform operations work. So really what we're talking about here is essentially using a Git repository to be the source of truth that declares entire environments, and then that source of truth will always try to be emulated by something. So I'll give you a cute picture here to help you describe it or help you see it. So essentially, typically how this works is any kind of GitOps tool, there's a few. I'm going to cover one of them today. Any kind of GitOps tool gets deployed within a Kubernetes cluster alongside your application. And this GitOps tool will become a quote unquote an operator. And an operator is just the name of a pattern. So an operator pattern is essentially a daemon or a background thing that just performs operations work. And that's why it's called an operator. So this DevOps tool, this GitOps tool is going to be deployed on your cluster. And it's essentially going to watch a Git repository for Kubernetes manifests. So if you're familiar with Kubernetes, you know that you can define a YAML file that describes a Kubernetes deployment, and your YAML file will point to containers that it's going to run, right? And your deployment typically is the name of your application or service, and what container images it's going to use. So everything in Kubernetes can be described through a YAML file. And so when you commit the manifest that describes your application to a Git repository, then essentially an operator that is watching that Git repository will ensure that that manifest is applied to that cluster. Okay. So it's almost like if you were to think of a thermostat, where when you have a thermostat, right, you set some temperature. And when you set that temperature, the system, the HVAC system, will try to meet that temperature. In the IT world, we didn't necessarily have something like this prior to GitOps, but with GitOps, we can start to think this way. So when you define an environment composed of Kubernetes manifests, and you commit that description of that environment to a Git repository, when you use a tool, a GitOps tool, you essentially have something that is always trying to match that desired state and ensure that all the things that you commit to that repository are applied. Okay. So this is pretty useful because if you're familiar with microservices and you worked in a microservices style architecture, you know that there can be a lot of complexity for that. But one of the main goals and purposes of microservices is that, individual teams are trying to deploy independently from one another, and in a way they're able to not have a monolithic release where they have to coordinate a bunch with each other. And so by breaking up the architecture, the monolithic architecture, they can deploy a lot more often. And if you try to have traditional CI/CD pipelines deploying microservices, you know that typically, there's quite a bit of steps trying to build your application, publish it to a container registry, and then have a bunch of steps to deploy your application. And it grows in complexity the more microservices that you have. Okay. And so one of the biggest benefits of using GitOps is to deploy your complex architectures in a way that is not too complicated, so that you don't have a Rube Goldberg machine of pipelines, right? In a past life, we were working on a microservices style architecture with, I think it was like 15 microservices. And in order to create a new environment and deploy all those microservices, we had to trigger 15 different pipelines to point to that new environment so that we can deploy, a cohesive application. And what we ended up doing was we ended up creating a pipeline that triggered pipelines, the pipelines of pipelines, right? And with time, we figured out that was going to be a pain because the moment you added a new microservice or your pipeline changed, it would essentially could break your pipeline of pipelines and everything would kind of go stale, right? So I know that was a lot of information, so I'm going to give you a quick demo of what I'm talking about. I'm going to give you a quick demo of using a specific GitOps tool called Argo. And Argo has gained a lot of popularity in the open source world. It's one of the leading GitOps tools. There are other GitOps tools out there. I'm not necessarily going to cover the other ones through demos, but I'm just going to focus on Argo for this one. So let me switch my screen here. Okay. Is this clear? Yes. Somebody said yes. Okay. Hopefully. If you can't see it, then Santosh, feel free to pipe up and say something, but I'm not necessarily looking at the chat right now.
That looks
Okay.
good to me.
Okay. Sounds good. So I have this demo application. It's called Weave Socks, and it's kind of a socks e-commerce website. And there's lots of cute things you can do with it. I mean, you can add things to a cart and you can purchase socks, right? It's really goofy, but what it's meant to do, let's see if I have a diagram of it. I don't have a diagram on it. But essentially, it's a microservices style architecture. There's, I think, 7 different microservices. Some already in here, preview. A second here, I'm trying to show you. Okay, perfect. So you can see here that there's several microservices. There's a carts microservice, there's a catalog, a front end, orders, payment. There's even a queue and a RabbitMQ queue here, and some type of session database, a shipping microservice, a user microservice. So there's a lot's going on, right? And at the end, there's a front end kind of collecting everything together. But with in a traditional world, if you were trying to deploy this entire architecture, it would be kind of a lot of work and maybe a lot of trial and error to stand this up. But with something like Argo, what you are able to do is you can define an application. And in this scenario here, you can see that it's called sock shop. So you can define an Argo application that points to a repository. And the repository is just a Git repository that has a bunch of manifests of what this application should be, right? So this is vanilla Kubernetes manifests here. So we have services, we have deployments, we have lots of things. And essentially, when a file changes on that Git repository, Argo will sync up with it and figure out the drift and reapply the manifest so that it would essentially push the update to your application. Okay. So when I dive in here into the application definition, you can see that this is quite overwhelming, but this is all the Kubernetes resources that this particular application has. There's deployments and services and configuration maps, and I think there's even an ingress there. So there's lots of things and lots of resources that by just simply defining a Argo application, pointing it to a Git repository, Argo was able to deploy very quickly. So let me switch back to the slide deck here. Another benefit of just using something like GitOps is detecting divergence, right? So by divergence,
Facundo,
I mean, yep.
Right. Question. So, you showed how Argo is connected to the application, the Git repo, and then the manifest. And when it detects a change, it goes through and builds the manifest and then deploys, right? And so, what is, like, when you say deploy, what does it exactly do? Can you talk about that a little bit more in detail?
Yeah. So let me switch back to okay. So let me grab this cards thing. All right. So everything in Kubernetes is YAML, right? This can look a little overwhelming, but this is a deployment file that's already been deployed to Kubernetes, right? And essentially what Argo is doing behind the scenes is anything that, okay, let me back up here. So let's see. Okay. So the way that you can deploy a simple YAML file to Kubernetes is kubectl apply, and you give it some YAML file. So it doesn't matter. It doesn't matter if that YAML contains a service or a deployment, a secret, a configuration. As long as you define whatever you want to deploy to Kubernetes as YAML, then you can just deploy it with a simple command. Okay. So essentially, what happens with Argo is that, as you can see, you have manifests that are committed to a Git repository. And when Argo detects a change from within the cluster, it would apply this operation. It would essentially deploy an entire directory, because this works as well. You can deploy an entire directory of YAML files to Kubernetes. So that's essentially what Argo is doing. It's watching some repository, maybe a folder within a repository, and when it detects a change, it would just call Kubernetes apply, and Kubernetes will figure out how to essentially upgrade your application. Did that make sense, then, Tosh?
Yeah.
Okay.
Sorry, I was trying to come off mute. Go ahead.
Okay, perfect. All right, so let me show you what would happen if something that tries to do something bad. Okay, so again, let me look at my deployments. So I have a carts microservice here. And what I'm going to do is so I'm going to delete this deployment. And you can see that right here on the right-hand side, Argo said that it is out of sync. It just went yellow all of a sudden. It detected a change. It detected that there is a carts microservice that was deleted from the cluster that's supposed to be there because it's part of the repository. So what I can do now is I can sync it up again so that this carts microservice gets redeployed. And I just clicked a button here, but you can configure that to be automatic. There's a capability called a self-heal toggle there, where if it does detect a change, it would self-heal on its own. But right there, I first synced it. So essentially, it saw that I did something bad, and I deleted the deployment, and then now it's trying to create it, and it should be right here. It's creating. There's a little spinning toggle. Let me try to zoom in. So now it's syncing up with a repository, and it's recreating this cart service. Oh, and I just did it again. So let me sync it up again. And it's there again. It was created by Argo, and now the application is just rolling out. Okay. Oops. Okay. Now, if you happen to work for a company that's more in the kind of manufacturing realm, or maybe more of an ISV, where you essentially have like locations where you deploy your code to, or maybe it's more of customers, right? So every customer that gets onboarded, then essentially you create a new environment for them. Then something like GitOps could make a lot of sense because it provides a lot more simplicity. Let's say that you have 5 separate environments, because these clusters are a combination of customer cloud environments, or maybe even physical locations within some type of corporate building. If you were to do a traditional, deployment model, you would essentially need at least 5 pipelines to deploy your application to those clusters. But with something like GitOps, as long as you have Kubernetes clusters with a tool like Argo installed on them, you can point them to a Git repository, and the moment you commit a change to Git, Argo would ensure that those applications are deployed and up to the latest. So what I'm going to do is give you another quick demo here of how easy it is to redeploy this complicated microservices app. Okay, so my card service is still spinning up, but I'm going to delete the whole thing anyway. Let's see. So I'm going to go ahead and delete this socks application. I'm just going to do it from the UI. You can see it's deleting. Things are disappearing. There's lots in here. Things are disappearing. Might take some time. More deployments are disappearing. So I think what I'm going to do is I'm going to come back to this because it's going to take a little minute. Oh, there we go. The application's gone. Okay. So what I'm going to do now is I'm going to recreate it by essentially telling Argo to create a new application. And I'm going to tell it to look at that Git repository right here. And that's pretty much it. So I'm recreating the application. You can do this from the UI as well. I just didn't want to make any mistakes because you can see that there's quite a bit of text boxes here that you can put in. But essentially, I just recreated the application to that same Git repository. And now it's recreating all the microservices from scratch. And there's all the deployments there again. Ooh, I just created the front end. And it's going to take quite some time, maybe 5 minutes or so. But you can see that it was kind of painless. Okay, we'll come back to that. What am I showing? Okay, there we go. We'll come back to that demo and to see, you know, how many microservices exist after a while. So another benefit of using GitOps is security, because as you can imagine, you likely need to give less access to people, because as long as it's committed to some type of Git repository, people have access to that Git repository. They, in a way, can create deployments. And as long as things are stable with your GitOps tool, then, you know, it's highly likely that people have to go into Kubernetes to figure out what's going on. On the flip side as well, if you can think about, if you ever created a pipeline, what typically happens is that after you build your application and you have some artifacts, you have to push those artifacts to some server or push your artifacts to a container registry, or in this case, Kubernetes, right? And when you're pushing or starting a new deployment, you typically need access from the pipeline to be able to perform that operation. And so if you have a microservices style architecture with 15 different pipelines, you essentially need 15 pipelines with enough permission to deploy to Kubernetes, right? And so from a security standpoint, your blast radius tends to go up quite a bit more because you have a lot more things that are able to access your cluster. When you use a tool like Argo, because there's nothing pushing code or creating containers within Kubernetes, you know, there's only a GitOps operator that's watching from within a cluster to a Git repo, and it's only polling for new changes. And so there's no need to essentially create a new credential to have a new pipeline deploy something to that cluster. So it just makes things a lot easier from a security standpoint. And typically when that's brought up, a lot of people like that aspect of it. So I guess what can I show you here? I don't necessarily have a demo for this one. So the last benefit that I'm going to point out to you from using GitOps is that, we've all been there where essentially we're trying to troubleshoot why our application is not working. And, what change made our application break? And because with GitOps, you're inherently always using Git, it means that you're always getting an amazing audit trail of all the changes that happen within your environment. So if an environment is unstable, and especially if you have alerts going off in your environment, you can correlate, when an alert went off and who committed what change at what time on a Git repository. So it makes things quite a bit easy to troubleshoot. And especially if, everything deployed within the Git repository is 100% the source of truth, you will know that nobody necessarily went into that cluster and deployed something out of source control or made a modification to a configuration setting somewhere on your application, and it was never committed to source control. That probably wasn't the case because they're using GitOps. Any questions so far?
So a couple of questions. You talked about deploying the changes, but what are some strategies / recommendations for A, rolling out the changes, and B, rolling back the changes, like blue-green deployment, canary? What kind of rollback strategies, stuff like that? Can you touch on some of those, or are you planning to do that? I'm just curious.
I can. I didn't want to get too deep into that realm, but I can. So let's talk about it from an audit perspective, right? So let's say that something went wrong in your environment and you're able to trace it to that commit on your Git repository. Because you're able to see the diff of the thing that broke the environment, you have two options. You can either somehow trigger a rollback process, but what's likely more easier for you, especially since you know exactly what changed, is to just roll forward and just grab a commit that reverses the past commit, so that essentially you have a new version of the application or configuration, and you just roll it forward. You just treat it as another deployment. What I can talk next about is an advanced kind of deployment strategy that can be really, really beneficial for developers. And I'm not necessarily going to talk about Canary, but it's something called preview environments. So I think that's a good segue into that. So preview environments are, imagine if you could create a change to your application. Let's say that you're changing the color of a button from green to red or something like that, right? And let's say that your environment is quite complicated, so you're making this change on the front end, and then you have all these different APIs and databases that are also required by your application to work. In the traditional world, you would have some type of shared dev environment, and sometimes you'll be stepping on each other with other devs. But in a cloud native world with the power of containers and the power of Kubernetes and the power of GitOps, you can actually create an environment that's just a preview of the change that you're making. So let's say you change the color of the button from green to red. You start a pull request And the moment you start the pull request, then there will be an automated process that builds your branch and then publishes a container to whatever container registry. And then it essentially, using GitOps, will create a new application with the source code that you just created from that pull request. And it will live alongside the typical environments, like your dev environment, and it would be your own private environment. So it could even be to the point where you essentially, open the pull request, your code gets built, some automated process creates your preview environment, and then gives you an URL that you can go and preview your changes. And you can play around with, your source code being deployed in your preview environment before you merge it to your main line of code, master or main. So I have a demo of this kind of working, and it may or may not work. So we'll find out together. By the way, it looks like our last demo worked just fine, right? So we have a healthy entire microservices architecture here, deploy through Argo. Everything is green, everything is fine. So I'm going to use the same strategy here to essentially create a new environment for this application, but only from changes containing from my feature branch. So let me go over here to a different desktop. Okay, so this is a different Argo instance as well. Okay, so let's pray to the demo gods together, and hopefully this will work. But let's say that I want to change this button offer today from red to green. Okay, so this repository here is the source code for the front end of my microservices. And there is a folder in here. This is the top bar, right? So I'm going to change that button. Why is it blue? Oh, I forgot to create a branch. Oof. So you can see that in the master branch, the button was blue. It was set to the Bootstrap button info, right? So let me create a new feature branch. I'm going to call it feature. And I'm going to, what color should we make it? Green. We're going to make the button green. Make button green. Okay, there we go. So now we have a feature branch. And then now I can go into the top bar. And I'm going to change the color of the button from blue to green. Oh no, that is too literal. Button success. Okay. Did I misspell it? No. Okay. So far, so good. Commit the changes. Sorry about this. This was a dry run of the demo. So I know I'm really confusing you with all the colors now. So this was a past feature environment that I created. So what we're really trying to do here is create a green button. So now what I'm going to do is going to create a new pull request. I'm going to make the button green. What is going on? Things are being typed backwards. I don't know why. Okay, I'm not going to go to the upstream. There we go. Button is green. So I'm going to start the pull request. And there should be a GitHub action that's going to build the front end and publish it to a container registry. And once it does that, then we can kick off the next stage of the process. This is like watching a pot boil. All right, there we go. So the container was built. I'm going to ask you to use your imagination here to get the second half of what an amazing life could be with preview environments. But imagine that some bot commented on this pull request and said, you know, your container was published. So I'm going to go to my container registry and I'm going to see the tag for that feature branch. Okay, so this is the new container image for that feature branch. And then also using your imagination, let's see, create preview. Also using imagination, pretend that what I'm about to do here on this terminal session is essentially something that was also done by the GitHub action, right? So what I'm going to do is tell my fancy script here that this is the new container that was published for my feature branch. Oh, whoops. I didn't give it any name. Override it.
What are you trying to do right now, Facundo? Just benefit.
Yeah, give me a second here. Debug in real life. Log. Refer to commit. I made a mistake, you know. Okay. Let's see if this works. Okay. So what my awesome script did was essentially something that could be run from a GitHub action, but essentially what it did is it also created an application within Argo. And it's telling Argo, here, create this new application and also use this image here, which happens to be the image that we just published, right? So if this script that I ran up here was run from a GitHub action, essentially it could create a new application definition for Argo so that when I commit my new application definition, it would essentially deploy an environment containing all the changes within my feature branch. Okay. So I'm pushing it now. So now we're looking at Argo, you can see that there's a new application that popped up here. It's in yellow. This green one is one that I did prior to this talk. So this is an existing preview environment I already had created. But this yellow one is the one that I just created through this file right here on the right, pointing to the source code of that feature environment that we just created. Okay, so it's syncing, and inside of here, you can see lots of microservices, including the front end, and things are slowly spinning up. So once this finishes, essentially, we're going to be able to preview the change that I did. And what was the pull request? I forget the color. So we should see a green button instead of this red one. After some time. It's going quite quick. Any questions that anybody might have right now?
So the usage of preview is interesting because, sorry, because what I've seen is the name matters a lot. People use preview usually post production or something, and this almost seems like this is a pre-dev preview. Is that accurate? What the type of workflow you're doing here?
Exactly. Yeah. It's to be honest, it kind of renders your dev environment, your shared dev environment kind of useless, because imagine that there's 10 developers all making changes to this front end, right? And the moment that a developer creates a pull request, they're going to get their own preview environment with only the changes that they had isolated from all the other developers, right? So potentially people could iterate a lot quicker, and they can even talk to QA and see if they're on the right path for making a change, all before things are merged back to the main branch. And this is also really useful for front-end development, because at least in my experience, it's a bit rare that people create unit tests and even integration tests for front end. So front ends are quite brittle, or they can be quite brittle. And especially with a microservices style architecture, like it can be really hard to have a stable front end without having some kind of deployment pain, because people keep stepping on each other, or there's a huge backup of features, So it's quite promising. Did that make sense, Santosh?
Yes. The other question I had with Argo is, obviously you showed a single deployment to using Argo, but most of the pipelines that we know and use, they deploy from one to the next, and then they do the whole. Some deploys are automatic. For instance, dev to test is probably automatic, but stage to production, they may gate that process. So I'm assuming this is all supported, right?
Yeah. So that's kind of how you set up Argo overall. There's different strategies. I mean, it could be quite advanced, and I might lose you all, but you can deploy Argo to a central cluster, where it could this central cluster could become your tools cluster. And then you just have downstream Kubernetes clusters for each of the environments, like dev, test, production, or whatever. And based on branches, Git branches, you can isolate those environments. So that's a common way to isolate changes from one another. The way that Argo is deployed right here, as I'm showing you right now, it's within that same cluster that it's deploying to. So potentially you can also have decentralized Argo. So, you essentially would have a dev, test, staging, production cluster, and each of those clusters you have a separate Argo instance, and you isolate environments based on branches or even folders. You can do that as well. So something failed here. It got really close. It looked like it got super close. It was just the front end that didn't work for some reason, some kind of race condition. I might try to kick it again to see if it works. And if it doesn't, we just give up on it. You can do it. All right, last try, last try. Nope. We got so close. So close.
That's
Anyway.
always the fun with live demos. Right?
I know.
Yeah.
And I had so many, I think I was too ambitious. Okay, maybe I'll circle back at the end to see if somehow things have self-healed. That's totally a possibility because of GitOps and Kubernetes, but I'll move on to the last bit here to recap. All right, so when is GitOps a great fit? When you don't necessarily are able to deploy your application in a serverless fashion, or you can't use platform as a service offerings in the cloud. So, deploying from feature branches is not necessarily a new thing. You can do that with platform as a service offerings on Azure, GCP, AWS. So it's not uncommon. Also, when you have a lot of controls at the enterprise, right? So one of the main reasons why an enterprise company might not let you use serverless or platform as a service offerings is because they have strict controls about the firewalls that they want, the network rules going into your environment and leaving your environment. So when you use serverless and platform as a service, you lose a lot of that control. And so therefore a company might push you to use something like Kubernetes. And that leads you into, of course, to use GitOps in this context of within Kubernetes, you need to already have played with Kubernetes or have been using Kubernetes. And it might make sense when you have lots of environments and you have a complicated architecture like I was showing with microservices, and you just have people stepping on each other, right? I worked with a company where they had a team of 100 developers creating this complex microservices style architecture, and they had, I think it was about 3 or 4 teams that all needed to change code in the same front end. And they constantly were having issues because they were stepping on one another. And, if a developer from one team destabilized this shared dev environment, then it kind of slowed the entire sprint to a crawl because the entire shared environment was unstable. And sometimes it also prevented from the application to be tested by QA, because if you had an unstable dev environment, that you can't necessarily give it to QA to have it tested. before you deploy to production. So there was constantly a lot of roadblocks of people stepping on each other. And so when you start to discover the use of GitOps for declaring your complicated architecture in a declarative way, and you could take it a step further with advanced deployment strategies like preview environments, then you have the capability of being able to remove some of those roadblocks, like we were talking about with having each front-end developer have a preview of the change they're about to make. And so they don't have to run the risk of somebody else stopping them from completing the work that they need to get done. So that's all I have for today. And sorry we couldn't get that last demo there going. I was really hopeful that we would. I'll check it right now, but does anybody have any questions or something that did not make sense and would like me to try to explain again?
Not that it didn't make sense. I'm trying to discuss the whole preview environment that you showed. It's a very interesting concept. It seems like it's triggered by a pull request process. And I guess my question is like, that seems kind of expensive for a pull request, depending on, your size and frequency of pull requests. Do you have any thoughts on like how to like what are some recommendations for the pull requests, like how to size and plan for that? Like it seems like it could get really expensive depending on how often people are doing these, right?
Yeah. So it's cost versus benefit analysis, right? Maybe it doesn't make sense to have preview environments for the backend services because typically, at least in my experience, it's a lot easier to unit test or write integration tests for backend code. And it's a lot easier to create microservices rather than micro front ends, right? So maybe preview environments could be a place where it just stops the pain point of developers stepping on each other for just the front end. And maybe that's the only place that you implement this. And the other aspect of it, right, is I'll share the amazing YAML that I have over here. So if you look at the right on my application definition for this preview environment, so this is the Argo definition, right? There's a toggle here for prune. And pruning means that if it doesn't exist in source control, then it's going to perform destructive actions, right? So in this scenario, because I defined this application with prune set to true, if I were to go ahead and delete the file from the repository, so if I were to delete the application definition YAML from the repository and commit it back, then Argo would destroy the entire stack. So I guess I could try that, right? See what happens. Sync it because I'm impatient. I'm only doing this because I'm impatient. And then if everything worked, then this should go away. Maybe. We'll see. So you can imagine that if this were to work, right? And because I deleted the environment definition from source control, essentially, as soon as you merge a pull request to the main branch or the master branch, you can have another pipeline that triggers and essentially deletes the file. And so Argo will get trued up to that, and your ephemeral preview environment will be gone. Oh, hey, it went away. There we go. See, I deleted the file, and then one of the large rectangles went away. All right, let me.
Yeah,
let
I
me
thought
see
so. I thought I was seeing things, but that makes sense.
Let me try to sync this again one last time to see if we're lucky. Oh, hey! The front end is creating right now. Wait. Sock shop. Oh God, can't type today. All right, there's the environment. Hey, what was the true color? Green. Okay, there we go. There's our preview environment. Sorry about the delay there, but this is a ephemeral environment that was created for a pull request, and there's our beautiful green button. Hooray, it worked after all, after some time. Any other questions?
All the code samples, the microservices and sites look beautiful. I want those code samples.
Okay. I still have to work out the kinks as you may have seen, but I'm happy to share that.
Cool.
Cool.
Anyone have any questions? Stopping the recording.